I'll try to write a function, a recursive function, to find height of the binary tree. So this is our tree. So first, how is gonna call it? We know that the height will return a height, and we will be calling height height height. And so here we are creating our function height, which will accept an argument. Let's call it pointer, and it will return integer. So what we do here, let's so suppose we are running this function, and this will be our first call. I'll put it inside the box. So in first call we have our p. This is our p, right? P, which is 1. We don't have anything else inside our function. So we know at some point in this function we will be calling height again. Height again, but this time we will be calling left, because in binary we usually go left, right? In binary trees. So we write it, and we came here and run this again, and we are here now. We are on our next call, which is again a pointer, a scoped local pointer pointing to 2. So we are here now, and we come here and run it again. So this is basically a function that does what we wrote here, nothing else. Now we are pointing to 3, not 3, 4, and last value is, so we're going left, and the last value will be 0.227. Okay, but still we are coming here and running it again, but this time the pointer will be null, right? So it's not necessarily, it is actually a call to another function. So it's somewhere here and it's null, so we need to let my function know that this is the end. So suppose we are here right now, so somewhere here I will write a function that will know that I am in the end. So this is the indicator. So in this case, what should I do here? Well, since we are measuring the height, we need the maximum height of here. So we might take this, which will be 2, but then we have this, which is 3. So we need to give preference to this height, which is maximum. So here in this case, this is it. If it were like that, we will accept it as another height, but since it's null, this is 0. So in this case we will return 0 here. Yes. So now what happens next? We came here giving back 0, but then we might have another, the right child here, which we didn't call, and we will call it somewhere here, let's say. because there is recursion, you have to enter everything inside, right? So we do right here. What is what is this? Right. So here I'm calling this, and it's same null like that. So it's here, then it comes back to this call, and returns 0. So now I'm at this point. What should I do? I have I have 0 from here and 0 from here in this function, but I'm not using them. How am I gonna use? Well, let me give and let me assign them to the variable. This will be our left, and this will be our right. Right. So in this call, I obtained from the bottom my left, which is 0, and my right, which is also 0. These two values. So I am here right now, and I am within this function. I am staying here. I executed this, now I'm staying here. So I need to do something with these values. I can just say return r plus 1 for the sake of using, but I have to implement a logic that would return something smartly, right? So since I am here, I will use them to indicate that I need a max. Whichever is max, that's the value I need to return. So how do I say that? I say if my left is bigger than right, then return left plus 1. That means or else return right plus 1. So whichever is bigger, and if they are same, doesn't matter. This one will work, and it still will be adding 1. So after here, after completing this statement, it goes to this statement 0 0, and it returns 0 from here. It returns 0. No, it returns 1 because we added 1, right? It returns 1. So in this call, our left becomes 1. As you remember, L1. Because in this call, so since we returned, we came back to this call, and in this call we only finished this call, and we still need to call this one, so we are now calling this one next. So we haven't obtained right value yet. We will be obtaining it now, and so in this call it's gonna be 5, right? So we finished 7, we finished no, okay, sorry, we finished 7. We are at 4 now. At 4 we are going here. We still need to go because we have this function, we have this statement. So we're going here, but then it's same. For consistency, I'll draw the box, and in here we are having 0, and we know from 0 we return 0 again. So our right becomes 0 here. Okay, now it's a little different. Here it was 0 0, now it's 1 0. So now while in this call, I am at this point now where I need to go through this logic, and in this logic all are left right, so my left is bigger, then return 1 plus 1, so it will return 2 here. So now our left is 2, and that's logical, right? We have 1 2. Okay, 2 here, and then 7 4 2. So in total we will have 3. So in this, and let's make this one. So it's gonna call this one is 5. So it's gonna call this box, and both will give 0 again, and this will give 1. So right becomes 1. Right becomes 1. And here I'm not gonna drop this. Will return 1, right? It will return 1. So this is 2, this is 1. The length of this one becomes 3. Right, right becomes left becomes 3 here, and right becomes just 1. Just 1. Or 2, I mean 2. Because here it was 1. Here it was 1. And then comes here as 2. It was 1 here, I mean. It was 1 here, and here it's become 2. So this one is greater. So when we are here, we finally return. Oh, I'm messing. This comes here as 2. This becomes a 2 inside the function, and this becomes 1. 1. So, and then here on my last call right here, I am returning 2 plus 1, which will return finally 3. The 3 is the right number, because I see that the maximum the maximum height that has in this tree is 3/8, right? So it's 3.